Hey everyone, so today I got a friend from Mississauga joining in. He's about to do a coding interview. We're gonna try to get through a couple questions in a span of 50 minutes. Spend about 20 to 25 minutes each question. Could you quickly just introduce yourself? Like, basically, just tell me what year you are in school, what companies you're aiming for, maybe how many leak code questions you solve, where you think you are with algos and stuff like that.
Yeah, hello everyone.
Yeah.
I'm a second year computer science student.
Yo, chat. How's the
I
audio?
wouldn't say I'm cracked by any means. I've done maybe 40 to 50 LeetCode questions and most of them easy. Um, yeah, just kind of wanted to see where I'm at and how far I have to go.
Nice, nice. Cool. Yeah, let's just get started with the first question. We're gonna go with we'll do some warm up. I'll post in the question.
Sounds good.
Yeah, I'll give it like, w yeah. Let's work through this question. This is the first question. So I'll say it at a high level. We're given a string, right? And we want to see if the string, we just want to return a boolean value. True if the string could become a palindrome, and false if it's not a palindrome. um, but we could remove up to one. We can delete one element there. So yeah, you can see the first example is just a palindrome without deleting anything, and then you can see example two is a palindrome if we delete one character. So we could choose to delete a character or not delete a character, but we just have to return a boolean if we did a or if it can get to a palindrome. Does it make sense?
Yeah, that makes sense. All right. So I see here you already have the constraints for us. Um, so that's
Yep,
convenient.
exactly.
I'm just gonna read over the question and then see if I understand it correctly. So, just to confirm, a palindrome is a word that's the same forward as it is backward,
Yep.
and we can have at least one character removed, so we can just ignore it and see if that string is still a palindrome.
Yep.
Okay, so let's see here. Immediately, like what comes to mind is maybe we have a pointer in the beginning and a pointer at the end, and we just constantly see if they're equal,
Mhm.
and we we have like a count of like differences, and if there's more than one that's different, then uh, we can just return false. Otherwise, we keep going until the middle character, and then we return true at the end if it does work.
Yep.
Um, so that's what I'm thinking right now. Does
For a
that sound
palindrome.
good to Coda?
Okay, let's walk through like example two. How would that work?
Okay, so I'd have a pointer, um, maybe here. Oops. So let's say if this was the word, we have a pointer probably at A and a pointer at the two A's, and essentially we should be good because they're both equal to each other. And then let's see here, we go on to the next loop. So we move B up one, and then we move C up one, and here we see B and C are different.
Mm-hmm.
Um, so we can try. Okay, I see here where I might be flawed because B and C here. Which one do we move up? Um, that's an interesting point because Actually, it wouldn't really matter in this case because if you remove the B or the C, it would work out.
Hmm.
So you get rid of any and see if that works. And in this case, let's just choose to get rid of the B. Oops. So if you choose to get rid of the B here, um, and we set both of them to the C, then we see that is indeed a palindrome, and then we can return true at the end. But it does feel convenient that it worked out here. I would imagine maybe, let's see here. Let's say we had a scenario. Over. Really trying to think this through. Um, let's say maybe this was separated by like a G here. A and B are the same, and then we say C and C. Would this still work out? If A and A, C and C is the same. So, yeah. Well, I guess in the case where they're beside each other in the middle, you can get rid of either, so it should not really affect us. Interesting. Okay, so in that case, I think I should start coding.
Let's
So,
see. Okay. So what's your solution for, okay, we have a mismatch. Which one do we delete?
mhm. We have A, C, B. I'm just gonna assume to remove the leftmost one for now. Um,
Left one?
or maybe we could check the next character over. Um, and see if any of the two characters equal to that next over character, and then from there we can do the comparison. Um, but we'd also have to check the constraint where the left side is not um, greater than the right side, because then that means we're overlapping. So, and if we do find more than one character, then I guess we could skip it over. Would that make sense? Or
Oh,
does
wait,
that
wait.
sound?
Okay. Sorry, I was looking at the chat. Could you quickly explain again, like what happens if we have a mismatch? Pretend like we have A, B, C, A, and then like D here. How do we handle this mismatch?
Okay, so we have the two A's at the end, then we check that and it turns out fine. Then we have the B and E. We do compare that.
Mm-hmm.
Um, we see that they're not equal. So to figure out which pointers we're gonna move forward, first of all, we're gonna increment our mismatch count, right? Because we know we can only change one character or remove one character,
Yeah.
and then we're gonna compare the next over character. So if it's on the left side, the next character would be D, and then if it's from the right side, we'd see it would also be D, and we would essentially compare does B and D equal? Because if it does, then we know that we want to increment the right side. We want to
Okay.
skip over the right one, and then with the opposite, when you have B and C, then if they're equal, so for example, if C and D were equal, then we skip over um, the left side.
Okay. I mean, try. Yeah, I think we can get to coding. Try it out.
Okay. So, assuming we get S as an input, um, I guess that's all we really need. So if we were to make a function is pal, and then we get S as a string.
Sure.
Okay. So really, we want to have two pointers, I guess. Um, our left side is gonna we're going to have our left and right side. Left side is just going to be initialized to 0. And then our right side is going to be set to the lengths of s. Oops. Oops. S minus 1.
Sure.
And then also, before that, we also need to check, because we know it's a palindrome automatically, if the length of S is equal to, so if it was anything less than or equal to 1, you can just automatically assume it's a palindrome. Or at least that's what I'm assuming. Is that safe to assume?
Sure.
And then maybe you can just return true right away. Oops. Okay. Oops. Okay, so we have our left and right pointers. So now essentially, while the left-hand side is less than the right-hand side, what do you want to do here? So as we discussed earlier, we're essentially going to see if our string of the left side is equal to our string of the right side. And if they are, then we can just continue. So no issues there. So actually, let me just reverse the logic here. Oops. So let me say we're only really concerned if they're not equal. So what do you do if it's not equal? We have our two A's. If we get outside of this, then we know that they're equal, so we can just increment our left pointer, and then we can also subtract our right pointer. Let's see here. Why is feeling at me? But otherwise, for here, now we're gonna deal with the case where they mismatch. So we have A and A. Let's use this as an example. So we know that in the second run where B and C, we're looking into that. With B and C, they're not equal. So we do need our other variable that keeps track of mismatches. Mismatch. I want to have that as E0, but we also know that mismatch is at 0. Let's see here. We have A and A, B and C. So we will first want to increment our mismatches. Oops. Let me see if I can just quickly pick that mismatches. And quickly check if mismatches is greater than 1, because that's all we're allowing at the moment, and we can return false if it is. Otherwise, outside of this loop in the function, we can just, I just want to remember to return true here. True. So we have our left here. Okay, so that's good. Okay, so we have our left side and the right side, and then mismatch the other one. Mismatches, okay. So now that we know that mismatches is less than 1, we'd probably want to see which pointer do you want to move, the left or the right side. So earlier, what I was saying was the B and the C. So let's see here. We want to look over at the one next over and compare that to see if they would match. So, so the first thing I'll probably check is if, since we're jumping over now, I guess we do kind of have to see if left plus 1, whoops, if left plus 1 is still, if it's greater than, and I'm kind of at the point where my solution is probably bad because I'm overwriting. Like the code is not very succinct, but I'm still gonna continue. Now. If left plus one is right, let's see here. I just want to recheck the condition just in case, because if left plus one or right minus one, so if left.
No, sorry, just talking to
Nah, you
somebody on the
good, you
chat.
good, you good.
Just talk to someone in the chat.
So let's see here.
So what's happening here? You're trying to figure out which one to delete.
Just give me a moment to think about this, because uh, I don't have much faith in my approach right now. So let's see here.
Yo, chat. How you think he's doing?
Yeah, the A and A. And I'm just thinking like hash map somewhere, maybe.
Hash map.
Listen, when you're confused, just throw a hash map at it. Okay.
Okay, where are we at right now? Like, okay, we're removing the left and right pointers. That makes sense.
Mm-hmm.
If there's a mismatch, we're gonna increment the mismatch. I think everything is working there properly, but
Mm-hmm.
where you're trying to figure out is like, what do we delete?
Yeah, which pointer would you move up? Um, Honestly, like, let me see here. If B and C are not equal, just ignore either one of them. Doesn't matter. But in this case, we have B and C here. Which one do you move up? Okay, let's say like this was B. Um, Naturally, you would want to delete the D itself. Oh, that's interesting. I did not even account for that in this scenario. So you have
Okay,
AB.
let me think about this case. Back up real quick. Oh, sorry. What if this was a B? Who are we deleting?
We would definitely delete the C.
Okay, we delete the C. Okay,
Let me just think about
what if we had
that.
this? Which one are we deleting?
You would delete the C still.
On the left
So
side, right?
yeah.
Okay, I'll give you a
So
small hint.
mhm.
Just try deleting both and return true if one or the other works.
Okay, so you delete the B and you delete the C. Let's see what would happen there. So you delete the B and you delete this.
Or
So
no,
if you just
try
move up both.
deleting one or try deleting the other. You can't delete both. You only get one deletion, right?
Okay. So if you were to delete, okay, so let's say you delete the left one and then you see if that works, and then you delete the right one to see if that works. Okay, and then you go with the one that works.
Uh huh.
Now that makes sense. Okay. So you have the left one and then you have the right one, and then you delete the one that wouldn't work.
Mm-hmm.
So you have C. Okay. So you have your left pointer, you have the right pointer, A, and then you go C, B. And then let's say you want to try the left side first. So you delete the left side by moving the pointer up, and then you return it back if it doesn't work. And then, okay. So in that case, so what I would do is I would compare. I would move the left pointer. Okay. That makes sense. That makes sense. Okay, so I would move the left pointer up, see if it's equal to the right pointer. And then if that doesn't work, we're gonna try one more. We're gonna return the left pointer back. And then we're gonna try moving up the right pointer. And if that works, we're gonna continue with that, but we're gonna keep the mismatches +1.
Yep.
Okay. So we have S of L does not equal to S of right. You add the mismatches +1. So what we want to try is here. We want to see if. Let's first try moving up the left side up 1. Oops. Let's see here. So you have S of L, and we're gonna try moving up the right side up first. We're gonna see if that's equal to s of the right. So if it is equal, then we can just continue on to the next loop. So we continue on to the next loop, and then if, let's see here, if s of, oops, right plus 1, oh, sorry, minus 1 here, uh, is equal to s of L, then we also continue. And before we continue, we probably, let me see here, am I forgetting something? So I've never actually added 1 to L, so let me just quickly do that. Add 1 to L here, and then here, I never actually subtracted 1, so we probably want to do that before we continue, otherwise it's going to be an infinite loop. And then from there, let's see here. Now, how would this work? So let's use our A, C, B, B, A as example. If I just copy that down. Oh, it seems like I kind of got rid of my check for mismatches real quick. Um, so when we add the mismatches, I still want to see if mismatches is greater than 1. If it is, you also want to return false here. Okay. So that looks good. Okay, so now let's do a quick dry run to see if everything's working as intended.
Yeah.
Let's see here.
Okay, I think it makes sense. Let's move on to the next question because we want to make sure we get like more
Sounds good.
questions in. I'm gonna put in the next question or leave that there. We're gonna go below and I'm gonna ask you the next question.
Sounds good.
Let me.
Okay. Let's see here.
So we're gonna be given two sparse vectors.
Mm-hmm.
Compute the dot product of these two sparse vectors.
Okay, let's see here. Um, so I haven't have the slightest idea what I'm looking at here, but I'm gonna try and
I
look
can
at this.
explain what the dot. Well, the dot product is pretty much multiply each element by like the. So index 0 here has to be multiplied by index 0 nums 2. Index
Mhm.
1 needs to be multiplied by index 1 of nums 2, and then you sum all those together.
Oh, so essentially you multiply the first element of both. I mean, sorry, each index to its corresponding index,
Yeah,
and then from there you add up everything.
yeah. What like try it out on the input and see the output that you get.
Yeah. So here, I guess it would be 1 times 0, so it'd be 0 plus. I guess the first 3 would be 0 because you're just multiplying 0, 0. 2 and 3 here we have 2 times 4, that would be 8. So, and then you would have 3 times 0, which would still be 0, and then you end up with 0 at the end. So it'd be equal to, okay, makes sense. Um, okay. Honestly, this one doesn't seem too bad at all. So what I'm thinking is you just have 2 point, oh, sorry, just want to confirm if the length of the two nums will always be equal.
Yeah,
Okay. In that case, you would just have a pointer in the beginning of each one, and you would multiply them, add it to your current sum that you're keeping track of, and you would continue on until the for loop ends. And that's about it, really. And then you just return the sum. So this one doesn't seem too bad.
mm-hmm.
Okay. So in that case, I'll get to coding it. So dot. Hopefully this name is not taken. dot product, and then we have, um, let's say, I guess you're taking, oh, you don't have to worry about types, but I guess it would be still an integer, or would it be, I mean, sorry, float. Forget, cancel what I said. Just forget it. I'll be honest. Just you get the
Yeah.
two variable, two lists. So we have list one. So let's just call it list one, and then would have list two.
Sure.
And then okay, so essentially you would just have let's see here. You would just have result, which is going to be result sum, I guess I could call it. Give it initial value of 0.
Chat, what
And
do you
then
think so
for
far? GMT saying he's jumping around a little bit.
I guess for
What do you give him
index
on the first
in
question?
range
Out of 4.
length of, I guess we can use any list because they're both the same, really, length. But maybe if they were different, we'd use the minimum and then we would process the end of the second list later. But from there, I guess we have the index, we have the list, so you just want to do sum plus equal the product of. Oops, I just realized I called this result sum. And then we just do list one of index times list two of index. And so when this for loop ends, we would go through the whole array and then return result sum. So let's just do a quick run.
Yeah, let's do a dry run.
Okay, so let's say we got these inputs. Oops. One more. Oops. Okay, so let's say we got this over here. Oops. Okay, so what would happen is we first have our first variable, which is result sum, and that's going to be equal to 0 on the first run. Then we're going to have our index, which is going to also be equal to 0 on our first run. From there, we're essentially looking at, let's see here. We're looking at the first index here. Oops. So you could imagine how this would go. So we're trying to add, what's going to happen after this runs, you're basically adding 0 to 0. So you can just skip over that because the result sum won't change. And then our second iteration, conveniently can move both up at once. That's also going to be 0, so you can skip over that. And let's just skip over all the zeros here because we know 0 times anything is going to be 0. 0, 0, and then we go here. So we finally, in this loop, we're going to know that we're going to have to add 6 because 2 times 3 is going to be equal to 6. And our index here is going to change. So it's 0, 1, 2, 3, 4. So we know that this is a fourth index. And I just realized I'm kind of assuming that the code is going to work. I'm not really running through my code. So let's actually do that. So now we know index is 6. And then the length, we have our list 1. We have our result sum, which is still equal to 0. And then plus 6. Because we know that our index is 4. So what that means is it's going to head over to the fourth one. And you're going to do 2 times 3, which is going to equal to 6. And then we can skip over 5 here because we know that 5 is 0 as well. So let's head over to, and let me just increment my result sum. So now that we know that result sum is 6, and we know that we're in the last element here where it's 6, 6, and then we know that 4 times 0 also is 0. So at the end we return 6, and is that the same? It turns out our output is going to be the same. So even in the last index, we're adding 0. So our output is going to be 6, which matches the correct output. Does that look good? I can't hear you if you're speaking, but I do see you typing. So.
Oh crap! 1 sec. Sorry, I messed it up. Okay, we're gonna change this up a little bit. Sorry, my bad.
Mhm.
Can you hear me now?
Yeah, I can hear you.
So we're before like what we're gonna do is we're gonna create this dot product class where it
Mm-hmm.
has a constructor. In the constructor, we're gonna pass in the first list, and then
Mm-hmm.
we're gonna have dot product, right? Which is
Mm-hmm.
gonna take in a second list, and this dot product could be called up is gonna be called 1,000 times
Mm-hmm.
with different list,
Mm-hmm.
right? So
Okay.
how would you update this code so that we can call this dot product with different lists and compute the dot product against list one?
So sorry, you said compute the dot product against which list?
So we're first we're gonna create a dot product, right?
Mm-hmm.
And we're gonna pass in list one, which is gonna be
Okay.
something like this, right? And then later we're gonna compute dot product like
Mm-hmm.
this with a bunch of different lists, right? We're gonna
Okay.
call it up with 1,000 different lists, and the lists are gonna
Sounds
be
good.
like different. How would you
So
update this
list
code?
one stays the same?
Yeah, list one stays the same.
Okay. So I would probably just have um maybe a final variable up top with oops. I'm not sure if final actually works this way in Python, but I'm still gonna type it out anyway. Oops, probably should not use something I'm not familiar with in the interview.
Yeah.
But I'm just gonna say final underscore list one. That's kind of wordy, but I think it should do the job. And then set it equal to something that probably shouldn't change. Which list would you be using?
Well, okay, we're gonna instantiate dot product with list one, and then we're gonna call dot product 1,000 different times with a second with different
Uh,
lists, and we need to be able to output the result.
okay. So in that case, I'll probably just say final list one. Um, let's see yourself, just so that we can know which list for which object because we might have different lists for different objects. Just call this list one is going to equal to list oops list one. Um, I think that should be enough for initializing anything really.
Okay.
And then for our dot product, we know that we have list two, so but we probably just can use the length of. Oh, sorry. So I just realized I didn't check in with anything. So we can still assume all the same constraints from before, right?
Yep.
Okay, sounds good. So we can use any list. So I'm just gonna use the list they. Oh, do we need to do any input validation? For example, if list two or too long or anything.
I think we can assume that the input is correct.
Okay. So in that case, even though we can use the length of list two, I would just to be on the safer end, I'm gonna use our very own list one,
Hmm.
just so we can keep things safe. And then from here, we would just do our own self of list one, um, and then we're gonna times it by the list two that we get, and then we can return the result sum. And yeah, I think this looks about right. and
Okay.
this should.
So I mentioned that the okay. What's your time and space complexity here?
I would assume everything is O of n because we're doing one path through, starting at the beginning and going to the end, and
Okay.
we know that addition multiplication is all just O of one, so it doesn't
What a,
really affect.
what about space?
In terms of space, here we'd have O of n for this list, and then our input would also be O of n, um, and then we'd have O of one for storage here, our
Yeah.
result.
Well, actually, our
So
list two here is like we're not really using us. We're not creating any extra space when we're given the input, right? But we are creating extra space here.
yeah. So in that case, it would just be O of n, and you can assume result sum is negligible.
Okay. I mentioned that the vector was sparse, right? So
Mhm.
is there any way that we could optimize for space here?
Okay. Let's see here. For space, I mean, we can turn it into an ordered set if that exists. I think it was ordered dictionary, but essentially, no. But then you're not keeping track of which indexes. One second. Let me see here. So we have a list one. If you have zeros, a bunch of everywhere, and then you have ones here. Hmm. Assuming, um, assuming that the list would be very, very large, and mappings between, uh, let's say we have 0, 1 here.
Like pretend we just had a massive array. All of it was zeros for list one,
Hmm.
and then just like one something there, right?
Hmm.
And then like okay, then we'd create a copy of that, and we're storing it in there in list
So
one, right?
what's coming to mind is we process list one first, right?
Sure.
And essentially we get rid of everything that's not zero, and we store the index it's at, right? And the current number
Okay.
that's actually stored. Um, and then when we're iterating over our list two, we can skip through everything and just focus on our our key value pairs in our dictionary.
Mm-hmm.
So in that case, let's in our initializer, I if we had more time, probably make a separate function and could just call it setup or something. But let's just do it in our initializer for now. Um, so for so this won't change our time complexity, I guess, but for our space complexity, it should help. For num in let's see here. All right, we still have our list one. So for num in let me see here. Let's just use index for example, because we need that as well. So for index in range length nums, we call the list one here list one. Let's see, list one, and we're gonna have to have our dictionary as well. So self dot, um, let's call it I guess dict mappings. Okay, hopefully that's not a reserved keyword. And we just have it empty for now. And essentially what we're gonna do is anytime trying to remember self-dict mappings. So for if index is, I mean, sorry, if list one of index does not equal to 0, then what we could do is just store it into our hash map. So I'm trying to remember actually how to do that. Here, I think we can just say this of the key, which is going to be our index, is going to equal to our value, which is going to be equal to list one of index. List one of index. Oh, oops. So I'm also going to need self here. Okay, so index. So essentially, what now we're doing is we have a dictionary that's hopefully much, much smaller than our original input.
Mm-hmm.
That only has two pairs. That only contains pairs between indexes and values.
Mm-hmm.
Um, so now we can actually get rid of this list one completely because we don't even need to store it. Um, and then for our dot product, let's see here. So we were currently before we were iterating through the length, but now I'm trying to remember. I think there was function class called enumerate. So we're going to do index and value, and probably enumerate over our dictionary. Let's see here. Um, Actually, let me see. No, sorry. Completely lost the plot here. I don't know what I'm doing here, but I'm gonna do. Um, Pretty sure. Let me see here. Self dot data mappings. So now, trying to think. I think this. Okay, we're not getting the value here, so I'm trying to remember. Was it dot values or was it enumerate? Let me see here. No. Or maybe it was a dot item. There was some function, convenient function, for this to work. Well, regardless, you know what? Let's just do this.
I think that works. Yeah. Let's assume that items returns. The first part is the index, and the next part is the value.
We could. I think we could also do this just so we can have something that works. Um, so if you just go through every pair and then you just say index, comma val, and then we can just say pair. You know what? Let's just assume it works.
Yeah.
Okay. Um, okay, so oops, index and value.
Like
Index
I mean,
and
we're
value.
not running the code, so we're
Okay,
good
sounds
to
good.
work.
So yeah, we have the index and we have the value, and we still have our list too. So what we're gonna do is we're still gonna multiply the index of our second list, but for our first one, we're actually gonna the value stored in our hash map. So I'm just gonna copy over this and paste there. So essentially, whichever value is stored with our key value pair is gonna be the current number at that index, and we're gonna multiply it times our list two of index, and this should be a lot quicker.
Mm-hmm.
Hopefully have a lot less memory involved, assuming that zeros um, assuming that there's a lot of zeros. So like maybe as long as the length of our dictionary times two, if there's more zeros in that in there, um, in the list that we started with then this should be a lot more space efficient. Otherwise, if our starting list is much smaller, then it wouldn't really matter.
I see. Okay. Nice.
But it'll still
Cool.
be faster in terms
Yeah.
of like
Because now
speed.
you're literally like for that big one, you're only gonna do like one operation, which is like capture the first
Mm-hmm.
index, or because you only have one element in the index, or one element in the hash map, and then you only look in the list two like once.
Mm-hmm.
I think right. Yeah.
Yeah, that makes sense. That would make
So
sense.
cool. All right. How do you think you did?
Um, I would say depends on what the bar is. If it's definitely like Fang or anything, big tech, definitely flopped. But if it's like a decently just a Fortune 500, I think personality hire maybe. But yeah, that's about.
All right. Yeah, definitely personality A plus. I'll give you my feedback. Honestly,
uh,
You almost came back from a 3-1. The first question was definitely like a no, but the second question was definitely a yes, right?
Mm-hmm.
So between averaging those two, I'd still lean towards a no. But I think with enough practice, you're definitely going to be able to get a yes, and from there, able to get to a strong yes. I think that was a solid performance, especially for a second year. I'll tell you what you did good and what you did bad.
Mm-hmm.
Let's start with the first question. You're able to clarify the question well, like figuring out like what a palindrome is, and then walking through approach. But the main thing you couldn't get there was the edge case of which one should I delete, either delete the left one and the right one, and then I had to give a hint there, so that's why I had to like drop it to a no because I had to give too much of a hint. But I think even if I did get the hint, I think you'd still be able if you were able to actually implement it based on the hint. I would have given a yes, but even the solution that you implemented after still wouldn't work. Are you able to follow my cursor here?
Let me just scroll up. I think. Okay,
Yeah,
so
like
now I see
here,
it.
yeah, you're gonna either remove one or the other. But what you could do is like because you need to try both scenarios. So one way to do is like recursively, like try delete one pointer and then recursively see if that's gonna return true, and then try it for the other one. Because here, how do you're not able to try both cases in this one,
Mm-hmm.
right? But I think
Yeah.
overall, really good job of able to understanding the question at a high level. I think for second year, you're really good. But yeah, able to talk to a thought process. I think how you do your interview is good. You just need more practice because you couldn't get to optimal solution. So
Sounds good.
yeah, so that was the first one. The second one you did a lot better, but I have to judge you on both of the questions.
Mm-hmm.
That's so I think the second question is you're able to talk to a solution. You do know Python syntax really well. You're able to get to the optimal solution. You definitely know your fundamentals of like throwing a hash map at it.
Mm-hmm.
You just need more practice, man. That's it. But I think how many
Sounds
questions
good.
have you done in general?
So this is the okay. I've alone without looking at any solutions like 40 to 50,
Hmm.
but I've done about 180. But just watching like Code videos when I'm bored.
Nice. Okay. Now you're good. Like for a second year, you're better than I was at a second year. I think definitely, yeah, cracking Fang, it would have been a no for, but for other companies, yes. But and it's not like a hard no. Like you're really close. I could see that you. I think you're just getting through the questions slower than we need to. You need to be a lot faster at coming up with the solution, talking through the edge case. Like there's still a lot of room for improvement.
Yeah, and hopefully I can come back in 3 months much
Yeah, let's
better,
get
and we
it.
can
Yeah,
do
I'll
it.
message you, and then
Sounds good.
I think one more thing would just be have proper use snake casing because you're in
Mm-hmm.
Python and you're doing
Mm-hmm.
camel case. So I would use snake case. That's about it. But
Sounds good.
overall, really good job, honestly.
Nah, I
Thanks for
appreciate
coming
it
on the
so
interview.
much.
Yeah. How do you feel? Like, did it help the interview? And
No,
like, how do you feel
hundred
about the
percent.
feedback?
Honestly, amazing because like I'm not gonna lie to you, I flopped so many interviews this year, including the most recent one being Apple. So
Wow. No. Okay,
like
we're gonna
I've
get you
always
right, man.
never took Code serious, but now I'm starting to think like maybe I should lock in a bit. You know what I'm saying?
Yeah.
So I'm
Honestly, you're
excited. You
really
know?
good. Like, you just need more practice. It looks like you have the fundamentals.
No, like I'm definitely hyped. Like, don't get me wrong. Like, I'm looking forward to this.
All right. Okay, I'll hit you up again in
Appreciate
three
it so
months.
much.
Like, I got your email. Just email me
For
when you're
sure.
ready for when you think you could get the next ones. Like when you're
Sounds good.
ready. All right.
Thank you so much. I
Catch you,
appreciate it.
man. Have a good day. See ya.
See ya.